Welcome back! In the last lesson we dipped our toes into Python, writing and running basic scripts. Now it's time to dive deeper, to immerse ourselves in the diverse world of data types. Understanding data types isn't just important, it's indispensable, especially for engineers, scientists and analysts who deal daily with an array of information, be it numbers, text or intricate lists of data points. Now, let's unravel the most common data types you'll encounter, one by one. First up, we have integers and floats. These are two data types that you'll use frequently. Integers are whole numbers, like 1, 10, or -3. They're useful when dealing with the discrete values, such as the number of units produced by a machine or the count of experiments that are conducted. Floats, on the other hand, are numbers with decimal places, like 3.14 or -2.718. These come in handy if you're working with continuous data, such as measurements of voltage, temperature, or the results of a scientific experiment where an element of precision is key. Here are a couple of examples of how we might define these in Python. We might define the number of components as an integer. This could be the number of components that are manufactured. In our example here, we have 63. Temperature is a value which we would use a float to define. In this case, we have 23.5 Celsius. These distinctions are important because they determine how Python handles these numbers in calculations. Next, we have strings. A string is a sequence of characters. Think of it as text. In Python, strings are enclosed in either quotes or double quotes. Strings are particularly useful when you need to work with non-numerical data, such as labels, names, or descriptions. For instance, in an engineering project, you might use strings to label different data sets or identify materials. For example, you could have a material and you would give it a name of aluminium. Moving on, let's discuss lists. A list is a collection of items of any data type. It could be integers, floats, strings, or even other lists. Lists are incredibly useful when you need to store and manage multiple related items. Imagine that you're collecting data from a sensor that records temperature readings throughout the day. You could store these readings in a list, and your data could look like this. You would define a temperature value, and then lists are always defined with square brackets. So you open your square bracket, put your first value in which case here we have 22.1, comma, next value, comma, etc. Commas always denote the separation of values in a list. Then at the end, you close your square brackets. Finally, we have dictionaries. Now, a dictionary is simply a collection of key value pairs, where each key is associated with a specific value. This is particularly useful where you want to map relationships between data. For example, if you have multiple sensors in an experiment, each identified by a unique ID, you could store their readings in a dictionary. Here we have a variable called sensor readings. This is a dictionary when we use a curly bracket to define the variable. Each of your keys here, and the keys are each of those different sensors, has to be enclosed in quotation marks. Then you use a colon to define the value or the set of values that are associated with each of those keys. Dictionaries allow you to organize and access data efficiently, which is especially valuable in complex experiments or simulations. Now that we've covered the basics of data types, let's jump into our development environment and see these concepts in action with a quick practical example. Let's imagine we're analysing data from a basic weather station that measures pressure, temperature, and provides a location identifier. We'll define 3 variables to represent this information using different data types: pressure, temperature, and location. For pressure, we're going to give this a value of 1012 hectopascals. And we'll leave a comment there with the hash indicating that we're writing a comment just with the units in case somebody else comes across our code and doesn't understand what units we're using. It's always a good practice. For temperature, we're going to give this a value of 22.5, and that's going to be Celsius. Our location, London. This is a string, and remember, it's enclosed within quotation marks. As you can see, we've got an integer for pressure, a float for temperature, and a string for location name. Let's display these to check their values. Okay, I'm going to run the script. So that's it. You've now created and printed values of different data types in your development environment. This is just a quick demonstration, but it shows you how simple it is to work with variables of various types. In the next lesson, we'll dive deeper into how we can manipulate these data types for more advanced operations. But now let's just quickly summarize everything that we've covered. So to recap this quick lesson, integers, which are used for discrete values like counts and identifiers, floats, which is used for continuous data such as measurements and results of scientific experimentation, strings are used for textual data such as labels and descriptions, lists are used for grouping related items such as a series of readings, for example, and dictionaries are used for mapping relationships such as sensor IDs and their readings. These data types are the backbone, the very bedrock of most Python programs, especially in engineering and scientific fields. Whether you're analyzing experimental data, modeling a physical system, or automating a process, you'll encounter these data types continuously. In the next lesson, we're going to take our first steps into the world of Python libraries. We're going to unlock the power of one library in particular, a library that helps us work with data more efficiently and also transforms data into insight through statistical analysis. Until then, experiment with creating and manipulating variables using these different data types. Mix them, match them, store them in lists or dictionaries, discover what happens. I'll see you in the next lesson.